And so what we're going to do is we're going to see if we can find this resultant force, but then more importantly, we're going to go put it in SolidWorks and make sure the computer gets the same answer that we do. Why? Well, because it helps, because it's like visualization and helping you figure out, like, I don't know, just sometimes it helps to put it in SolidWorks because then you can, like, instead of looking at this on a piece of paper in 2D, you can, like, rotate it in 3D and get it from a different angle and be like, oh, I get what that force is doing. So this can be really helpful. But of course, the first step is to solve it on paper to make sure we can verify what we're doing on a computer. All right, so let's call this force F1. What we're going to do is we're going to start off by identifying all the different forces and their x, y, and z components. F1 is relatively easy. 0, 0, 200. We'll call this guy F2 because he also looks less complicated than his counterparts. All right, let's see. He's only in his ZY plane. So there we go. And let's see. So he's like this, and his components are proportional to 3, 4, 5. He's at 100. So that means that his parts are 5 times 20 is 100. 3 times 20 is 60. 4 times 20 is 80. So those are his parts. So Y is 80. Z is 60. F3 is going to be funner. Funner. Okay. These are always kind of fun. And by fun, I don't know what I mean because I don't actually mean fun. But these are always fun. All right, so I'm going to draw this 400. So basically what's going on is it's come out along this line, or along the XY plane. It's come along the XY plane out at a 45-degree angle, and then it's kind of created this other plane here, and then it's come 30 degrees down on that plane. Okay, and this is where I think that the whatever you call it, SolidWorks thingy comes in pretty well, because you can actually draw that plane and see where it is. So that's going to be fun when we get there. So take it from someone who's had to record this video, 2, 3 times because of doing stupid stuff. You don't want to do anything stupid on this next step. Okay, so I actually got through the entire video, got to SolidWorks. SolidWorks gave me the answer, and I'm like, this is stupid. What's wrong with SolidWorks? So it turns out SolidWorks isn't stupid. I am. Okay, so we're going to look at this 400 Newton force. Now, this 400 Newton force is contained in this plane. This plane is going to become important later because we're actually going to recreate this plane here in SolidWorks. Okay, so we have this plane that's coming out like this. So this is the plane that we're drawing this triangle in. And I'm going to redraw that 400 because it looks like it's in a weird place. So we've got this 400 Newton force right here. Now we have this right angle. We know it's a right angle because it's contained within a corner of the box that has not been interrupted. So that's definitely 400. Now this is important to make sure you get the 30 degrees in the right place. Also make sure that you recognize what that 30 degrees means. So if you're likely to do something stupid, go ahead and redraw it to emphasize where that 30 degrees is. Okay? With that 30 degrees there, that means that the 200 is here, and this side is 200 squared to 3. I cannot emphasize enough that it's important to get this right. Because basically what that means is that we have 200 newtons right there. So that's our 200 Newton, and this is our 200 squared to 3. So we're going to look next at this triangle right here. Okay, so this triangle right here, all right, you want to identify the right angle, which is the uninhibited corner. All right, so now I'm going to actually redraw that as a real triangle. All right, and the upper corner here is 45 degrees. Now, opposite of that green corner is the 200 squared to 3, which means that this side is 100 squared to 6. How do I know that? Well, 100 times the square root of 6 times the square root of 2 is 100 times the square root of 3 times 2, because the root 2 comes out here. And so 200 square root of 3. Okay, that's that. All right, so I have the 100 root 6 and the 100 root 6. And so that's going to be my positive y direction and my positive x direction. Why am I drawing it that way? Positive y direction, positive x direction. Okay, so it's all about visualization. Visualization can be one of the main reasons that you have a hard time in statics, is you just physically cannot see the problem, which is again why we're kind of trying to do some of these statics, the SolidWorks thingies, to make that make sense. All right, so I've got 100 squared to 3, or 6 in the x direction and the y direction. And then in the z direction, I have negative 200. It's also important to get the negative signs in the right place, which may or may not also be another reason for doing these videos 10 billion times. So I have a 0, 0, 200 force. I have a 0, 80, 60 force. And I have a 100 square root of 6, 100 square root of 6, and negative 200 force. Oops. Now, theoretically, if I add all these together, that plus this, and I ask for an approximate answer by hitting the green key, I've got 245, 325, and 60. So what did I say? 245. And 60, positive 60, yay! All right, so that's my resultant. Now, if I'm looking to get the magnitude of the resultant, one way that I can achieve this is by taking this, well, the square root of the sum of the squares. So basically 245 squared, and then 325 squared, and then 60 squared, and that's beautiful. If I want to do this in my calculator a little bit faster, is to do the square root of the dot product. So if you remember, if I have a, b, and c, and I dot it with itself, I get a squared plus b squared plus c squared, and then I can just take the square root of the dot product, and I get that. So I'm going to square root my dot product of that with itself, and then I'll get a, oh, thank you. I'll get a magnitude of 411. So the 411 is really want to keep an eye out for. That's my goal, is to get the 411, and I want to see how close I can get to that. So now let's do that in SolidWorks. So here we are in SolidWorks. We're going to create a new part to correspond with what we're doing. Now the first thing you're going to notice is that or maybe not, but eventually you will, is that this coordinate system is stupid, because normally we think z is going up, and well, stupid in the context of, you know, engineering-y stuff like what we're doing. Because normally we expect z to go up, x to come toward us, and y to go out. Now you'll see it still follows the right-hand rule, x cross y is z with a thumb. So it's still okay, it's a totally legit coordinate system. Can we fix it to match? Yes, kind of. Is it worth it? Absolutely not. So let's not worry about it. Just for funsies, I'm going to sketch on the top plane. Sketch. Box. Box. No, not that kind of box. Not that kind of box. I want this kind of box. Delete that box. My escape key isn't working. Hop, choo. Come here. Box. 1. Let's say exit. I'm going to extrude 1. Now I have a nice pretty box. Do I really need a box? I need something to attach these forces to. Hit F to center. Make sure I'm in the right units. Options, properties, units, MKS, perfect, because I'm in newtons. Alright, now I need to actually draw lines where all these forces are going to come off of. So, in order to do that, first of all, I need a point, force point. So I'm going to select the side. We've been doing this a lot. There we go. And this is force point. What a lovely little force point. All right. Now the next thing that we have to do is we're going to have forces coming off of this. So we have a 200 force going straight up. So I can sketch on this plane. So I'm going to right click that plane. I'm going to sketch on it. And I'm going to just draw in a line starting from, well, here. And notice that little yellow thingy? There we go. So it says 101.04, 90 degrees, basically saying the line is going straight up. I'm going to say, yay, that's the line I want. Oh, but it's not fully defined. It doesn't really need to be, but I'm just going to do it anyway. I'm going to give it a formal length of 1. Beautiful. Okay, still not fully defined? What are you unhappy about? Let's go normal to that sketch and see what it's upset about. Because we don't want this to not be defined, so let's... Oh. That's weird. I must have accidentally done that. Let's get rid of that line. Or not. Alright, let me redo that drawing. A lot of times you're going to find that it's easier to just delete it and redo it than to fix it. So let's try this again. I'm going to go normal to this face, and I'm going to put in a sketch, and I'm going to start at force point and go straight up, dimension it at 1. Now hopefully it won't yell at me this time. there we go. Now there's no minus sign, so it's fully defined. So this is my line for 200 Newton force line. Beautiful. All right, now. Thank you. All right, so there's that line going straight up. Now the next thing is I'm going to have a line coming out here at a 3, 4, 5 triangle. Beautiful. In order to do that, I need to make sure I have a plane going through there. Now this plane that I have is actually on this side, so I actually need a plane that's going to go along this line but out. Now in order to do that, it's pretty easy. I can just create some reference geometry. So I'm going to go to reference geometry, create a plane. I actually already had the front plane selected when I did that, but I didn't have to. But here's the front plane. Now I'm going to say I'm going to go to this plane, and so I have front plane, face 1. Yours might be a different face, but notice that it says mid-plane, which means that it's creating a plane directly in the center, which is exactly where I want to be. So this is the plane that my 100 Newton force is going to be on. So I can call this 100 Newton plane. Do I have to name these things? No, it just helps later. So that's my 100 Newton plane. So I can say I want to be normal to that plane, and I actually want to sketch on that plane. I'm going to sketch a line. It's going to start at force point, and it's going to go like this. The smart dimension from here to here is going to be that's the 3 side. And of course my 3 button isn't working. That's amazing. Three. Come on. 3. Okay, I'm going to have to get that fixed pretty soon. Okay, my 3 button's not working on my stupid computer. All right, 3. It only works sometimes. Oops. No. And of course my escape key isn't working either. This is fantastic. Mayhaps I should get a real computer. Ooh, to force point to here, 0.4. All right, so that's going to give me the dimensions that I want on that line. Why did I do 0.3 and 0.4? Really just to keep it in scale with everything else. I could have done 3, 4, I could have done 30, 40, I could have done 0.003 and 0.004, and that would have been fine too. All right, so this is the sketch for my 100 Newton line. Okay, now what's nice about this is I'm not going to want this plane again, so what I can actually do is I can hide it, and then I don't have to see it anymore. So it's still there, it's just not visible. It cleans up my space a little bit. Now, the next thing that we have to look at is this stupid thing right here. So in this thing, what we're actually going to do first is we're going to create this top, I can't see what I'm doing. You're going to create this top box, and then we're going to go down from there, okay? So just so you know what we're doing, we're creating that top box. Now in order to create that top box, again, we need the right plane to do that because this plane's not right, that plane's not right, that plane's not right. So we're going to create another reference geometry. Plane on the top, plane on the bottom, mid-plane in the middle, all right. And this isn't the plane that the 400 Newton force is on, this is just an interim plane. Okay, so we have our interim plane for the 400, okay. I can make the plane bigger. I'm not actually, remember, the plane goes out infinitely in all directions. It's just, you know, I don't know. So this line right here that we're seeing is that 100 Newton line. We're just seeing it from the top. So again, the idea of doing this also is to kind of help you visualize what you're doing in statics and see what's going on from there. Okay, so what I had when I looked at this was a box. So from a top view, that was a box with a 45-degree angle. So that's what I want to draw here. Is I want to sketch a box coming toward me. It doesn't matter what size the box is, but what does matter is that we have a line going through it that's at a 45-degree angle. So I click those 2 lines, and now I can actually go and put in a 45. From there, I just have to arbitrarily assign the lengths of one of those, and now I have a fully defined sketch. But the point is that this is the first line, so this is a top view of this box right here. Again, it just looks funny. But that's a top view of this box right here. Okay, so kind of, again, like I said, the point of doing this in SolidWorks is to give you a better idea of what's going on. So then the next thing I'm going to do is I'm going to go down from there and find this 30-degree line so I can actually come up with that line right there. Okay, so let's see if we can do this. Now, what would be great is if we could just draw another box. The problem with drawing another box is we don't know the distance. We could calculate it, but then that's, I think, kind of losing the point. So what I'm actually going to do is I'm going to create a new reference geometry. I'm going to create a new plane that's going to use that line there as one of its references. That second reference is going to be, I believe, the top that we're looking at. So if you're kind of looking down on it, there's your center line, there's your top, and what that's going to do is it's creating its perpendicular to the face one that we've got there. So now if you go like this, aha, there's that plane that force is actually located in. So this is the plane for the 400 Newton force. Now, if there's too many drawings on here, remember you can go in here and you can hide pretty much everything that you don't want to see. I'm not going to hide the sketch because I want it. Maybe I don't. I'm going to go hide it anyway. All right. So basically what I'm going to do is I'm going to create a force that's coming out along this plane, and it's going to go down like this to be consistent with what I'd had. All right. So I'm going to go ahead and show that sketch just because that's helpful to me, because that looks like what I've got on my problem. All right, so I'm going to right click and I'm going to go normal 2. So now I am looking at a very strange angle at this plane, but again, who knows, maybe this will help make things make perfect sense. Okay, so now I want to create a sketch on that plane for that line for the 400 Newton force, and that's going to start here and it's going to go somewhere over here. Now, as you're drawing these, you really want to make sure that you're not accidentally, I'm going to delete this and show you what not to do. Don't click here and then accidentally go through that point, because then it's going to assume that you mean that to be a coincident point and you really don't. So make sure that, or even here, see how it's showing the little white line, that's all lined up, or that's, well, that might not show up, it's lined up here or whatever. But anyway, so just kind of put it into a point where there's no little add-ons to go with it. Now I'm going to smart dimension it because I know that from there to there is a 30-degree angle, except again I don't have a 3 on my computer because I can't handle the challenge of a 3. 30. Beautiful. And let's see, from here I just want to add an arbitrary length here. It doesn't really matter what that length is. I'm just going to call it 1, just so that it's fully defined. Now this is going to be the line for the 400. And now I can go in through here and I'm going to hide everything I don't need. And I'm only going to show the lines for the 3 forces. And so it's kind of the theory is that now you can look at this and get an idea of where those forces are and what they're going to look like. So there's a force going straight up, there's a force going straight out, and then there's a force coming at an angle. So it might help to show some of the planes, but it might not. It just kind of depends. But see, the 100 Newton plane is actually containing both the 100 and the 200. So in any case, this should give you some idea. Now I'm going to go ahead and re-hide everything that I don't desperately want to see. Okay. The next step is to go in here and create a simulation study. And I've done all the hard work. So I'm going to add my forces. This force is a selected direction force. It's going to start at force point, and it's going to go along this line. And its value is going to be 200. And I didn't check to see if it was in the right direction. Totally the wrong direction. Want to change the direction. There, I can see it now. So you can see it's going the right direction. Good. Now the next force I'm going to add is going to be, again, a selected direction force, starting at force point, going along this line. And again, you can tell it's going the wrong direction, but it's supposed to have a total of 100. All right, one more. Force. Select a direction, starting at force point, going along this direction. Its magnitude is 400. I can see it's still facing the wrong direction. Reverse the direction, and it's perfect. Now I'm going to go ahead and I'm going to fix the other side. So no, that's not what I wanted. I'm going to fix the other side so that it can't move. All right, now I have the three forces, and all I'm looking for is the resultant. Again, I'm going to save, and I'm going to run the study. Oh, silly girl. So, plain carbon steel, beautiful. I just did it. Don't yell at me. There we go. Now, again, to really not get too excited about this, because you look at this, these are extremely, extremely small displacements, so they're basically not there. And I'm going to look at my resultant force. I'm going to look at the free body. Now remember that if you don't have the free body option, you want to make sure that whenever you right-click this thingy up here, that under properties, that you have the free body forces thingy checked. If you don't, just check it and run it again. It's not a big deal. Seriously? Seriously? Okay. Let's try this again. Right. I'm going to click my force point, and this face, I'm going to say, give me some stuff. All right, here's the stuff. It says I have a 325 in the X, a 60, and a 245, resulting in a 411. Let's see if I'm anywhere near that. So I'm going to go look at my original calculations, and oh my goodness, this is so amazing. I can hardly contain myself because I in no way had to do this like 6 times and take 4 hours to get this to work. But it does work. I got the 245, 325, and 60, 325. Now you'll notice that the X, Y's, and Z's aren't in the right places, but we already talked about that. So we are super happy. Ignore the moments because they're super tiny. We don't care. But this is just amazing. Look at this. This is working.